So in this second clip, let's do another example. So in this first example, we followed certain steps. So exactly same steps we have to follow in the other examples as well. So let's see another example. Example, okay, 2. Okay. Earlier it was example 1. So let's take e power 2y minus y cosine of xy. Okay, so this is the equation which we want to solve. So now as you can see that in this equation, I think it's not possible to make it a separable equation by simple algebraic equation. So what we can do is we can check whether this equation is exact or not. Okay, so I will take, so this will be m, this is n. Okay, so partial m over partial y, differentiate it with respect to y, so it will be e power 2y, that will be 2e power 2y, and then with respect to y, so it will be now this is the product of two functions, so we will apply the product rule. So it will be minus y into minus sine x y sine xy. Okay, cosine is minus sine xy, and then from the chain rule xy, so x is a constant, y is a, we are differentiating it with respect to y, so it will be x. Okay, and then by the second chain rule, so it will be cosine of y into y, so it will be minus due to this minus sign, or what we can do is over here is that I can take a bracket over here, so that way I can put plus over here, so it will be derivation of y will be 1. Okay, cosine xy into, that is 1, derivative of y is 1, because we are partially differentiating it with respect to y. So it will be 2e power 2y minus plus xy sine xy, and then plus it will be minus sine xy. Okay, so this is partial m over partial y, so whether it is equal to partial n over partial x, so we need to check. So now we differentiate it with respect to x, so it will be we are differentiating it with respect to x, so e power 2y is a constant, so 2e power 2y into x, so it will be 2e power 2y into derivation of x will be 1. Then we are differentiating it with respect to x, so it will be for cosine xy it will be minus sine xy, so from chain rule xy, then it will be y, because x, we are differentiating it with respect to x, so it will be y. And plus this is the product rule is we are applying it, so it will be cosine of xy into derivation of x is 1, and then plus 2y, because y will be constant, we are differentiating with respect to x, so it will be 0. So simplify it, so it will be 2e power 2y, then minus plus y sine xy, and minus cosine of x y. Okay, so minus cosine of xy, so it is minus sine of xy. It is a little bit different. Is there any mistake? Let me see. Yes, there was a small mistake over here, because when we are going to differentiate with respect to x, so x into the derivative of this cos x sine. There should be x over here, x into derivative. Let me put x here. So there should be x over here, x, and then derivative of cosine xy is minus sine xy, and then from chain rule it will be y. Okay, so therefore it will be plus xy sine xy, and then it is minus cosine xy. So now we can see that partial m over partial y is this, and partial n over partial x is this. So both are same. So this means that the above equation is an exact equation. So for this exact equation, now let's go towards the solution. Okay. So for the solution, we will assume that there is this function f. Okay, and whose partial derivative with respect to x is equal to this function e power 2y minus y cosine of xy. So from here we can integrate it with respect to x. So e power 2y, so that will become x e power 2y. We are integrating it with respect to x, and then we are integrating it with respect to x, so it will be minus y, and for cosine the integration will be sine xy, and from the chain rule it should be xy, so y is constant. Okay, so it should be divided by y. Okay, should be divided by y, and plus g of y, that means a function in y which is a constant with respect to x. So in this case you can see that y cancels out with y over here. So here what I can write over here is that function solution function is x e power 2y minus I think this y is cancelling with y, so it will be minus sine xy plus g of y. So now we need to find this g of y. So for g of y, then we will differentiate f with respect to y. With respect to y. So now we are going to differentiate with respect to y, so it will be x e power 2y, so it will be 2x e power 2y minus cosine of xy times, or from xy it will be x, okay, and then plus g prime of y. So now we can compare this with our n function. What is the n function? N function is this 2x e power 2y. So now we know that n is equal to 2. I have to go back to 2x e power 2y, 2x e power 2y, and then minus x cos xy, so minus x cos sine xy, so, and then the last value is plus 2y, okay. So here you can see that both are equal. Okay, so this is x cos y sine xy, this is also here, and this is 2x e power 2y. So therefore, if both have to be equal, then g prime y will be equal to 2y. Okay, and then from here we can find gy, integrate it with respect to y, so it will be 2y square over 2, so it will be y square. Okay, and the solution function will be then, solution function will be this. Okay, so x e power 2y minus sine xy plus gy is equal to y square, and that should be equal to a constant. So this is a solution, this is the solution. In fact, this solution is in the implicit form. Okay, so this is the solution for this equation. So this solution you can verify it by partial differentiations, and then you will get the same differential equation over here. Okay, so now we can take another example. Example 3. So if dy over dx is equal to xy square, minus cosine of x sine x divided by y into 1 minus x square, then solve this initial value problem. So y0 is equal to 2. So we need to find arrange this equation into the differential form. So it should be dx, so it should be like this: x y square minus cosine x sine x dx plus y into 1 minus x square dy is equal to 0. So let's check whether it is an exact equation or not. So this is m, this is n. So partial m over partial n, partial m over partial y, which will be xy square. So it will be, we are differentiating it with respect to y, so it will be 2xy, and then it is sine x cosine x, so it will be all 0 because we are differentiating with respect to y. So partial n over partial x, so what is that? We are differentiating with respect to x, so y is a constant, so y times 0 minus 2x is equal to minus 2xy. So it's not same. In fact, I had made a mistake because when I put it like this, so then we have to bring dy onto that side of the equation. So it will be minus here. Okay, so then it will be minus here also, and then it will be 2xy. So the equation is exact. So now we know that the equation is exact, so we can follow the standard procedure. So we will assume a solution function f, whose x derivative will be this function m. So function m is xy square minus cosine x sine x. Okay, so if we want to integrate it with respect to x, so we can do that actually. So since this is sine x cosine x, so we can actually simplify it: partial f over partial x, xy square minus, because we know that sine 2x is equal to 2 sine x cosine x, so it is then equal to sine 2x divided by 2. Okay,